Okay, this message brought to you by Spindrift Sparkling Water, raspberry lime flavor. Very nice. So this is the problem that was laid out for us, and part A asks us to find the total current in this circuit. We've got 4 bulbs, we know all their resistances, and we know the voltage being applied to the circuit by the battery. And so what we can do is try to go right at the problem like this. All right. But although we know the total voltage, we don't know the total resistance. So this comes down to solving for the total resistance. Okay, that's fair. So what we should do here is realize that 2 and 4 are in series, right? Because whatever current is flowing through this circuit as it goes around, part of it's going to split off at this point, and whatever piece of it that goes through this branch, well, that has to be the same current through both 2 and 4 until it flows back together at this junction and then returns to the source. So start by combining resistors 2 and 4, or bulbs 2 and 4. So we have R24 is this, which, if we look at our values over there, is 50 and 100 ohms for 150 ohms. Okay, and the 2 and 4 is going to be in parallel with the bulb number 3. And if we sketch out using different colors the voltage values as we move around, then we can see that the voltage difference across the combination of 2 and 4 and 3 is going to be the same, sort of red to green there. So we can combine these two in parallel to find the combination of the 3. If you do that, well, what you've got is a 1 over 150 plus 1 over 75. And if we squint, right, we know we have a common denominator of 150. And then we've got 3 150ths. And so what you should get for your R234 is 3 over 150, which turns into just 50 ohms. Okay, so we're nearly there. What we need to do is maybe come over here just a little bit and realize that we have one more bulb to add, which is number 1, and that's in series with the battery and all the rest of this big block of resistors here. So all we need to do is to find our total is to add these 2 resistors. R1 is 15 ohms. We add to that 50 ohms, and we get 65 ohms of total resistance. That quantity comes over here. Okay, when we plug that in, you should get, here we'll double check it, 12 divided by 65, and that'll give you 1.85 amps. Okay, so that's part A. Part B asks us a different question. What power must be produced by the battery? Okay, this is just asking, okay, what's the total power being produced in this circuit? This is a pretty short calculation given what we already know from part A, because we know that P equals IV, and we have the total current in the circuit, and we have the total voltage applied to the circuit, and so we can multiply those two things together and get that it's about here I'll add another significant digit, 2.22 watts. We can confirm that with a quick calculation. Yeah, good. Okay, so C, which lamp or lamps is least bright in this circuit? Okay, now this is a little bit trickier. You could actually calculate this out, right? You could go and you could find all of the powers dissipated by each one of the bulbs. And for some that's easy, and for some that's a little trickier. But here's some logic, and it makes it tougher that they're all different resistances, right? So, what we can know right from the beginning, though, is that we've got 1, which receives the total current, and is low resistance. So if we're looking at, so we're asked which is least bright. If we're looking at that circuit, okay, well, P1, that has the total current going through it, and it has that 15 ohms of resistance. So it's not going to be a big power, but it seems unlikely that it's going to be the dimmest just because it has lots of current going through it. Okay, but we can come back to that one. Now P2, okay, well, that's 50 ohms, so it's going to be only a third of the resistance in that whole branch with 2 and 4. And it's also going to receive a small proportion of the total current, right? The branch there has 150 ohms compared to 75 ohms, so it receives only 1/3 of the current and of the total current, and 3 receives 2/3 of the total current because of that ratio in their resistances. Remember, inversely proportional to the resistance in the branch is how the current will split up in a parallel. So, all that said, what you can surmise from that is that this is going to be 1/3 total current, and you're multiplying that by 50, okay? So you're stepping down by a factor of 9 here because of the squared factor of 1/3, and you're stepping up only by a factor of about 3 on the resistance compared to P1. So P2 is definitely dimmer than P1. Okay, so that's our leader at the moment. If we look at P3, well, P3 has 2/3 of the total current, and it's going to have 75 ohms of resistance. Right, we're using the I²R version of Watt's law, and so it has relatively high resistance. It has 2/3 of the total current. So it's going to be way more than P2. And for P4, so the last one that might have a prayer of unseating P2, right, the second bulb from its crown, if we look at that, well, it's a higher resistance, and it gets the same current. Okay, so if we were sort of working through this logic from that point and not actually going and calculating these things out directly, we could pretty quickly get to the idea that P2 is the least bright because it only gets 1/3 of the total current, and it has a lower resistance than the other bulb in that branch. And that is that. All right, so we'll see you in the next one.